Ask everyone to join fast. We will like to start as soon as possible, and we will start with physics. Before we are going to start, I will give you a small introduction to all of you, okay? So that you will get to know what we are going to cover in this whole journey of our physics. So basically, if we will see, basically, let me tell you about myself. Myself is Ritesh Kumar Singh, okay, and I have qualified JEE in 2022 with a AIR of 182, and I have been pursuing my BTech in NIT Trichy, Electronics and Communication Engineering. So basically, in the this course of physics, we are going to see each and every concept in very detail, okay? So first thing we will cover each and every concept, okay, very detailed. It will be a very detailed class, okay? It is not like that ki, like we will see only the small portion and then sleep. No, we will going to go into the detail of every concept in such detail you won't see anywhere else. We will cover each and everything in very detail. That is the first thing. Second thing, after completing a chapter we will do a previous year questions, okay? That is our main target. This is our main target. We have to do each and every previous year question, okay? And see, I am going to suggest you one thing. Maybe you won't like it, but please try to solve SCV, SC Verma, book of physics. You have to solve it, because if you see the last paper of NEET 2025, you will understand that physics is not that much easy. So what is the reason behind it? Because day by day the physics is getting more tougher and tougher in a NEET point of view. So it is better. Most of the people say that for NEET student there is a no need to solve the SC Verma. But now I am suggesting you have to solve SC Verma, and we will solve SC Verma in the class. In the class we will solve. After completing the chapter, we will solve each and every question of SCV. And for you, remember that SCV is a Bible, okay? It is a Bible for physics. This is the Bible for physics, okay? You have to solve this book, okay? So and there are a lot of confusion in a student, like which book I have to follow, sir, which book I have to not follow. You have to follow what books I will tell you. You have to follow, don't go beyond anything. Whatever I am telling you now, just follow it blindly. I'm giving you 100% surety. You will get full out of full in physics. That is, I'm 100% sure. But you have to follow whatever I am saying to you. First thing, you have to do NCRT, complete line by line, line by line. I will teach you line by line. But what is your work? After I have completed a chapter, your work is to just read the chapter. Just read it from the NCRT. No need to do, just open the notes, keep in front of you, and read the book. And you will see that each and every point, whatever I am telling you, it is matching from your book. Okay? So that is the first thing. You have to read NCRT line by line. Just read it. No need to do anything else. Just read it after completing the chapter. You will understand everything. Then solve this. You have to solve it also. Whatever the problems given in NCRT, that should be given a first preference, because they are going to build your basic. Okay, this is the first thing. Second, now you have to go for SCV, SC Verma book. Now you have to go for this. You have to start from here. You have to do SC Verma each and every question, example and workbook. You have to do this each and every question. We will discuss in the class also, okay? Now the last very important thing, if something more you want to do, you are not satisfied and you want to do something more, and you want to confirm that you will get 100 out of 100 or full out of full in your physics, then you have to, last we can do is the NCRT example. NCRT example. Okay, NCRT example. So this is the thing, this is the books you have to follow. Books which you can follow. Beyond this, no need to follow any other book, just follow these books. These books are more than sufficient to bring. If you follow, if you solve all these questions now, I am giving you guarantee you will get full out of fill on physics. You will get full in physics, that is 100% sure, if you solve all these three books and if you follow whatever I am telling you. Okay, second thing, this is the what about the books. Now the second thing, how the lectures are going to be, how the lectures will be happen. See, the lectures will be going to be in a very detailed manner. That is the first thing I have told you, it will be very detailed. Okay, that is the first thing. Second thing, during the lectures, I will tell you the concept, I will give you the notes. Okay, I will write the notes with you. I will write a notes with you, and also I will provide it. Okay, notes will be provided, notes will be provided. Okay, so if someone is hurry to make the notes, no need of that. Okay, if you want, you can write a running notes. Running notes means the important points, some important point you can keep. Okay, but we will provide you the notes, so that is not a problem. We will provide you, so you can revise the things from here. Detailed notes will be provided, that will be my handwritten note, whatever I have written here, that will be provided to you. But while in the class, your focus should be on the lecture, not writing the notes. That should not be your focus. Okay, remember that you have to write the running notes. Running notes means important point, whatever the important point, just note it down. Okay, that is the thing. So third thing is that whatever your doubt, ask in the class. Okay, whatever your doubts, please ask in the class. Third thing, and fourth, very important, that after completing, suppose we have completed a one small topic in a chapter, then we will go for the illustrations. We will do some multiple illustrations on that topic. Okay, so you have to try to solve it without, before solving me. That is your aim. You should try to solve. Okay, try to solve the questions. Try to do as much as practice you can do. So this is the thing you have to follow in the while when I am taking the lecture. Okay, and the class will be not very serious. We will do something also, we will enjoy, make the class as much interactive as possible, and this will be only happen when you will interact with me. Okay, if you have any doubt, if you have any questions, anything, you can just let me know. Okay, then only we can make this session more interactive, and we can do the things very properly. Okay, till then, if anyone have a doubt, please let me know, and then we will start further. Okay, please let me know. And if you want to note down something, you can note down. Okay, please let me know if you have any doubt. Any doubt is there? Everyone should say no. No, 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 sir, only one person. Okay, okay, no doubt. So no, 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 no need to use DC Pandey. DC Pandey is a book for. It is a very advanced level book. You can. It is basically for JEE advanced point of view. Okay, so no need of that for you to use DC Pandey. Whatever I am saying, you just follow SC Verma. SC Verma is like Bible for physics. Okay, so whatever the questions you will get, and when after doing SC Verma, if you do, after doing SC Verma, if you do this NCRT exampler na, all the problems of DC Pandey will be covered in NCRT exampler also. Okay, so no need of doing the DC Pandey. Okay, that will waste your time only. You don't have that much of time. Clear? If any doubt, anything else? If you want to speak, you can switch off your mics also and you can speak, no problem with this. Okay. In spite of typing, you can unmute also, no issue. So shall we start? Are say yes or no. Shall we start or not? Okay. See, daily it depend upon your capacity, how much you can give. Okay, regularly. It depend upon you, how much dedicated you are. It's not. It's completely depend how much dedicated you are. If you are dedicated more, then you can give more time. If you are dedicated less, you will give less time. Okay, it's depend upon the dedication. Okay, so let's start. See, if you see the paper of 2025, the major portions, or in any paper of physics, you will find that the major portion is from class 12. In any subject, I'm not talking with respect to physics, in any subject you will see the major portion is from class 12. So our flow will be like this: we will first cover the some portions of the class 12 which is not linked with class 11th. Okay, we will try to cover that portion fast as possible. Okay, then after that we will jump toward the class 11th. Okay, because otherwise if I start with the class 11th now, most of the student will get like bored. Array, sir, unit and measurement, lot of things are there, so it will make you bored. Okay, in spite of that, we will first start with class 12th. If suppose someone have an issue, okay, like sir, why sir is starting not going in flow, no problem, I know how to teach. Okay, just be patient, listen everything very properly. Okay, and you will understand each and everything in very detail. Okay, everything you will understand. Just be patient, try to listen my thing properly and try to understand each and every concept properly. Just listen my words properly and try to understand it. Okay, so let us start. So our first chapter we are going to start is the electrostatics. Okay, so we will start with first chapter, electrostatics. Is it visible? This color is visible to you or not? Okay. So yeah. So let us start with the electrostatics. First, let me ask you one thing. What do you mean by electrostatics? Can anyone tell me? Please unmute your mic and tell me what is the meaning of electrostatic. Don't be afraid of, okay, I will tell wrong, what will happen. No, no, no problem. Just tell. Okay. What is electrostatics means? So everyone know English here, no? Everyone understand English or not? Everyone understand English. One person is saying that I am a Tamil medium student, sir. Everyone understand English, right? Okay, okay. Yeah. So what is the meaning of electrostatics? Can anyone tell what is the meaning of electrostatics? Anyone, anything you know. See, you have to interact with me. Otherwise, there will be issue. Yeah. Yeah, Ashima.
Like to study the stationary electric charge.
Yeah, yeah, correct, correct. Electrostatic means study of a charge which are stationary, or you can say which are at rest. Good, good, very good. So it is a study of a charge which is at rest. That is called as a electrostatics. In magnetism, what we will do? We will study the charge while moving. When the charge will move, then we will study. Okay, that is called as a magnetism. In electrostat, we will study the charge at rest. Statics means what? Rest, at rest. Okay, so we will study the things at rest. Suppose the charge is rest, what will be happen? That is our study is going to be. Okay, so let us start with a very fundamental thing. That is, my first question will be, what is charge? Because if we have to study charge, then we should know about the charge. So what is charge? How the charge is defined? See, charge is defined as a intrinsic property of a material. Intrinsic means what? Intrinsic, which is a property which is internal inside the material. You can't see it. Okay, you can't see it. There is a no way to see the charge. See, this pen has also a charge, right? But we can't see it. It is an internal property of this material. So what is charge? Charge is an internal property of the material. That is a scientific language. In scientific language, we used to say like that. But in a bookish language, how will you see? Charge is a property of material by which we can able to get the force of attraction or repulsion. Simple. But if you understand better, it is an intrinsic property of a material. So what is charge? It is a intrinsic property of a material. Don't type, okay, just because it will be take time for me to see the comment. If you just unmute yourself and you can speak with me, you can speak, no problem with, okay. It is an intrinsic property of the material. Okay, it is an intrinsic property of a material. Now if I ask you how many charges are there, how many types of charge,
Two type.
how many, sorry,
Two type.
yeah, what are the two types? One is
Positive and negative.
other one is negative charge. Okay, so if I ask you positive and positive, what the positive and positive will do? Positive and
Repel.
positive will repel each other. Yeah, repel each other. Negative and negative will also repel each other. Positive and negative will attract each other, right? Like in real life. In real life also you will see same type of person repel each other, different type of person attract each other. Okay, so that is the charge. Till here anyone have a doubt? What is charge? At least in a definition of charge, if anyone have a doubt in definition.
No, sir.
Okay, now next thing is the properties of charge. You should clear with the properties. What are the properties of charge? Okay, so let us start with the property of charge. Tell me the first property of charge which you know for. Okay, tell me the first property. Any property which you know. Anyone? Okay, let me unmute you. Uh,
Additive.
yeah, charge is additive. Uh, Yokesh 2007. Can you tell me any one property of a charge? See, you have to be interactive, otherwise it will be a, like a bore session. Okay, we have to be interactive. Try to be interactive as soon as possible. Okay, otherwise it will not be an interactive class. Now, then you will not enjoy it. Yeah, Yokesh, are you listening? Just unmute yourself. Conservation. Okay, okay. Yeah. So one of the property is also conservation. Any other property? Anyone else? Divya.
Quantization.
Yeah, quantization. Yeah. Mohammed Kasim. Any property you can tell? Let me know. Tell fast, fast. Mohammed Kasim.
Sir, uh, I'm not turning 12th standard, so I don't know about its properties.
Okay, okay, no issue. Okay, so let us see the properties as some of the persons have told. So the first property we will go in the order. The first property which is very important, one of the person told also, Yokesh told me also, that is a conservation. Charge is always conserved. Okay, remember this. Charge is always conserved. Okay, charge is always conserved. Now, what is the meaning of this conservation? Charge is always conserved. What is the meaning of this? Anyone know? What is the meaning of charge is conserved? What should I understand from this? Like if suppose I am a layman, I don't know anything. If someone say me a charge is conserved, what should I understand from this? Can anyone let me know? What should I understand?
So the isolated should remain constant.
Yeah, okay, so yeah, it's correct. Basically, for an isolated system means the system which is not in a contact of anything. Okay, that is called isolated system in a scientific language. Simple, you can say in a scientific language. See, everything in nature only, just we have given us some scientific terms to it. Okay, so isolated means the system which has no contact with anything. So the system for an isolated system mean the system which has no contact with anything. For me, or suppose I am an isolated system, so my the charge, suppose I have given a 2 coulomb of charge to me. Okay, 2 coulomb of charge is given to me. So if I am an isolated system, my 2 coulomb charge will no would don't go anywhere, it will be always remain on me only. So that is called as a charge conservation, means the total charge on an isolated system will always be conserved. Okay, so the total charge on isolated system is always conserved. Clear? So suppose if you understand this, then there is one question I should ask you. Suppose there is a one system is there. I don't know, some system is there, and suppose it has a plus 5 coulomb, plus 3 coulomb. This is the now here we have got minus 2 coulomb, and this we don't know. This there should be another charge should be there. I don't know. From here to here this system has went. Okay, can you tell me the value of this charge? What should be the x? If you have understand charge conservation, you can tell me what should be the value of x fast. Simple question, just do it fast. Anyone got the answer? Anyone got the answer? Please let me know.
10,
How much?
10.
How much? Yeah, 10. How? See, charge is conserved. So the initial charge, what is the initial charge? Plus 5 plus 3. That is the initial charge. That should be equal to the final charge, right? That is minus 2 coulomb plus x. So from here you will get x as 10 coulomb. Simple. See, total charge is 8. Here also, if you put 10 here, this 10 plus 2 is 8. So both the charge are same, right? Someone has answered minus 7. How? You have to do initial charge is equal to final charge. Okay, that is a charge conservation. Because the system is isolated, everything is assumed. Then only we can apply this. Okay, clear? Any doubt till here? Anyone have a doubt? Hey, you persons don't speak, man. At least speak. You have a doubt. Don't type. I am not able to see the comment section right now because I, while teaching, I cannot see. You have to speak with me. Okay?
Minus 8 can we use?
Sorry?
Sorry.
Okay,
No,
okay.
no, no.
Okay, okay. Please, everyone speak. I am not able to see the comments. Okay? You have to speak with me, whatever you want. Because see, while typing, you will sleep. I don't know whether you are listening or not. If you will speak, at least I will know you are listening me. Okay, clear? This first property is clear. Second property, I hope someone has told me the charge is always quantized. Okay, charge is quantized. What do you mean by this? What is the meaning of charge is quantized? What is the meaning of the charge is quantized? Can anyone let me know? What is the meaning? Hey, you guys don't speak, man. Speak. If you know wrong, correct, doesn't matter. You have to start speak with me. What is the meaning of charge is quantized? No one? Okay. See, the charge is quantized means, suppose I have a one conductor. Okay, one conductor. Suppose this is a one conductor and there is another conductor, right? Suppose it is a neutral. Okay, now it has a charge of plus 3e. What is e represent? Just try to understand. E is what? What is the value of e? Hey, what is the value of e? Anyone tell me what is the value of e?
1.6 into 10 to the power minus 9.
Yeah, 1.6 into 10 to the power minus 19 coulomb. So that is the smallest charge we can isolate, we can extract from any body. This doesn't mean that this is the smallest charge only. There are the some charges exist, like if you have read NCRT, they have mentioned 2 by 3e, 1 by 3e. These are the also the charges are there, but they are not isolated. They are not, you can say, they cannot exist in the nature. Okay, they cannot exist freely in the nature. They can't exist freely. Okay, they don't exist freely. Exist freely. And anyone know what is the name of this? What is the name of this? What is the name for these charges? These charges are named as, anyone know about this? What is the name of these charges? They are called as a quark. Quarks. They are called as a quarks. They cannot exist freely. That's why they are not represented as a smallest charge. Okay. If someone asks you what is the smallest charge, that is one electron. That is one e is the smallest charge. Okay. Because it exists in the nature freely. It can exist, but this can't be exist. Now you just come here. This is the smallest thing you can remember because it will be somewhere, it may be asked. Just remember this. And one more point, if you want, you can remember what is the mass of proton. Can anyone let me know? And what is the mass of electron? Can anyone tell me what is the mass of proton and mass of electron? What is the mass of proton?
Mass of electron 9.1 into 10 to the power minus 34 kg.
31.
Yes.
31. 9.1 into 10 to the power minus 31 kg. Okay. What is the mass of proton? What is the mass of hydrogen atom?
1
One, it is, you are telling in one AMU, atomic mass unit. I am asking in gram. Can you convert atomic mass unit into a gram? For converting atomic mass unit into a gram, we have to multiply it with some term. What is that term? 1.67 into 10 to the power minus 27 kg. Okay. So the mass of proton is 1.67 into 10 to the power minus 27 kg. This is the mass of proton. You can see the electron is very, very, very light as compared to proton. Okay, you can compare this term. This is very, very, very small as compared to proton. Clear? Now just come here. These are the basic thing. You should remember this thing. Okay, someone, suppose you're some younger brother and sister ask you, Bhaiya, sister, Bhaiya, what is the mass of proton, mass of electron? You should know all these things. Okay. Now let's come here. See, this is a body. Suppose it is initially at neutral. Okay, initially at there is no charge on it. Neutral means no charge. Now, after some time, I came from here to here, and now it has a charge of plus 3. And another same thing. Suppose this is the same thing. Suppose this is the same thing, and it has a charge of 1.5 e. You tell me which one is possible, which one is not possible. Which one is possible and which one is not possible. Which one is possible? This is possible or this one is possible? Can you let me know?
First one is possible
Why why second one is not possible?
because it comes under quark.
Yes. Because it is very good. It is a quark. If you see, it is made up of quark only, na? One, if I want to break this, I will break it how? It will e plus e by two like this. Yes or no? I can break it like this. So this is something which is consist of fractional part, na? It is a one of the quark only, which is not possible. Hence we can say that this can't be exist. This can't be possible. This is not possible. Not possible because I told you charge can when only exist in the form of e, not 2 by 3 e by 3, because they exist in the nature. This type of charge exists, but they are not freely exist. Okay, they don't exist in freely in the environment. So that's why we say that this type of charge we don't consider. So this is correct, this is possible, this is possible, this is possible. So from here we got one observation. Whatever the charge on the body q, that will be always an integral multiple of e. That is what called as a charge is quantized, where n will be what? 0, 1, 2, 3, like this up to whatever you can go. Q is equal to plus minus ne. That is what you understand. So what is the meaning of charge is quantized? Means the charge will always a integral multiple of a integer, or sorry, integral multiple of a e. And what is e? E is 1.6 into 10 to the power minus 19. Clear? Anyone have a doubt with respect to this? Anyone have a doubt? And no one is saying yes or no. At least say yes or no something. One more time. Okay, Yogesh, can you unmute yourself and tell me what is your doubt? What is the problem you got? Yogesh, Yogesh, are you listening me? Yogesh, can you unmute yourself and let me know what is your doubt? What is the problem issue you face? Yogesh, I am talking to you. Are you listening me? Like, what is your doubt? You are asking me to repeat once. Like, can you let me know what is where the problem you have faced? At
Sir,
least
can you say that how second one is not possible?
because it's, you can see now, it is a combination of e plus e by 2. E by 2 exists, sorry, e exists, e by 2 exists in the nature. Is it exist in the nature? What is the meaning of e by 2? E by 2 means you have taken an electron and break it down. Is it possible? Just try to think, is it possible? Because I have told you, they are, these type of charges exist, but they don't exist in the nature freely. You can't obtain a charge of 2e by 3, e by 2. Okay, this is not possible. Fractional charge you can't obtain in the nature, because for that you have to break an electron. Is it, have you listened that breaking of electron is possible in the nature? Can we break an electron? Electron is considered as one of the fundamental particle, right? We can't break electron. So that is why we say that the second one is not possible. Okay, because it exists in the nature. I'm not saying it not exists, but it does not exist freely. You can't get that charge in nature. You can't get 2e by 3 charge. It is not possible. Nowhere you will get this. Okay, clear? Ashima, clear? Your doubt is clear?
Yeah, sir.
Okay. Yokesh, do you tell me anything like you? Okay, doubt is clear. Like, what is your doubt? You are not replying to me. David. Okay, so till here, anyone have a doubt? We have covered the two properties. One is the charge is conserved, another one is the charge is quantized. Now the next property I would like to tell you is very important property, that is charge does not depend upon the mass. Okay, charge does not depend upon the mass. Is it true statement, or first you tell me whether I am saying true or false? It is a true or false that charge depend upon the mass? Is it true or false? Charge does not exist, you can say like that, charge does not exist without mass. My question is that whether this statement is true or false.
It's false, sir.
Okay, it's false. Can you give me one example, one supporting example for this? If it is false, can you just suggest me one supporting example? One supporting example. It's very easy. If you try to think, you will get. Is this statement is true first, true or false? You said it is false. Can you just tell me one supporting example? I need one example.
The electrons having mass, like the
If you take
electrons.
any particle, okay, let me tell you. You take any particle in the nature, okay? Obviously, it will have some mass, right? It will have some mass, right? Always, no particle in this nature can have no mass. Obviously, every particle in this nature have a some mass, right? So, suppose I am a particle, you are a particle, you are also a particle. Do you have a charge right now? Do you have a charge? No, right? There is a no charge. But you have a mass, right? You have a no charge, but you have a mass. So from this statement, what we understand? We understand, okay, mass can exist without a charge. Mass can exist without a charge, right? You can take example of neutron. Okay, neutron has no charge, right? What is the charge on the neutron? What is the charge on the neutron? Charge on the neutron is? Arey, you don't know what is the charge on the neutron?
Zero.
Only two persons are like speaking in the class. What about this other guys? Like, are you in the class or you just open the meeting and went somewhere else? Everyone should speak. I think everyone, some other person just opened the meeting and they went somewhere else, I guess, right? Just try to speak with me, okay? Try to unmute yourself, speak, then only you will understand. Otherwise it's like a boring, you are seeing some picture and I'm just coming and writing anything. It will not going to help you. Okay, you are preparing for one of the important exam, you want to become a doctor or whatever. So for that you have to be very much focused, you have to try to understand each and every concept, then only you can do the thing. And for that you have to interact with the teacher. Okay, you have to interact with that. You have to, like, I'm not your as a teacher, I'm your as a friend. If you interact with me, if you try to talk to me, you try to as much as interactive you will be with me, it will going to help you only. Okay, so yeah, what I'm saying, charge does not exist. So you can see that whatever the body we will take, it will always have a some mass, right? But there are the some bodies exist in the nature, they have a, what you can say, they have a mass but they don't have a charge, right? Neutron is one of the example. Okay, so that means we, from there only they have got a one conclusion. Okay, the charge does not exist with mass, that is a statement is true statement. If anybody in this nature, anybody saying, if it has a charge then it will have a mass. For example, electron, proton, okay, anything you can take. If it has a charge, okay, for example, you can take electrons. For example, you can take electrons. They have a charge, they have a mass both. Protons, don't put neutrons, okay? So if I ask you the reverse of this statement, reverse, what will be the reverse of this statement? Can anyone let me know what is the reverse of this statement? What is the reverse of this statement? What is the reverse of above statement? Are just you have to reverse the statement. How will you reverse it? It's a grammar, not a. It's not a physics. What is the reverse of this above statement which I have spoken?
Mass of charge exists without charge.
Basically,
Mass
the
of
uh,
particle.
it's okay. Basically, what is the reverse of the state? What I am statement I have told you. I have told you, charge cannot exist without a mass, but mass can exist without a charge. That is true. You can see neutron. Neutron has a mass, but it don't have a charge. So, what is the above reverse of the above statement? That mass can exist without a charge. Okay, mass can exist without charge. Okay, without charge. Mass can exist without charge. Okay, so for example, neutron. Okay, clear. Now one more property. The property is that if you see the charge is invariant of the speed of the particle. Charge does not vary with the speed. That is a very important property in real life. If you apply on us, for example, I want to apply this property on me, I cannot apply it. Why? Because my mass is very large. Okay, so here the speed is not and my speed cannot also, I cannot like get a speed of light. Okay, that is not possible for me. But if you see in this electrostatics, we will have a very small particle like electrons, protons, right? And what is their mass? Their mass is very small, very small. So for them, it is easier to achieve the speed. If you remember, what is the speed of electron in the first orbit of hydrogen atom? Then, did anyone know what is the speed of electron in the first orbit of the hydrogen atom? Okay, well, first let me know. Everyone who is present in this class, they are all are dropper, or they are, some are continuing 11th or some are in 12th, whatever. Like I don't know the status. Can you let me know about yourself? Like there, are you a dropper, or you are in class 12th or 11th? Which class you are? Like which what you are right now? Okay, class 12. Okay, Kishore is class 12, 12th. Okay. What about there? What about others? Okay, completed. Okay. Okay, okay. You, Muhammad Kashim. Okay, Muhammad Kashim, you are in class 11th. Okay. Okay, okay. See, those are in class 12th. I hope they have covered electrostatics, right? Did you have, those are in class 12, they have covered electrostatics?
Yes, sir.
Okay, okay. What, and those are in 11th. I will tell you that you just try to make a proper notes of everything. I will provide you the notes also, and try to understand the concept, each and everything. If you have a doubt, please let me know. And those who have completed 12, for them it is very important to understand each and everything. Okay, if you have a doubt, please let me know for you. Okay. Yeah, so if those, I'm asking to those who have completed class 12, do you know the velocity of an electron in the first orbit of a hydrogen atom? What is the velocity? There, you, can you let me know what is the velocity of electron in the first orbit?
2.18 something.
Yeah, it is 2.18 into 10 to the power 6 meter per second, right? Now you just try to see this figure. This is 10 to the power 6, right? And what is the speed of light? 3 into 10 to the power 8. Is this, both the speeds are very close to each other, right? Yes or no? Yes or no? Yes. So they are very close to each other. Okay. So you can understand here the speed is going to play a very important role. Why? Because our speed here in this case is very much comparable to light. So that's why I am considering this point, that the charge is independent of the speed. Okay, charge does not depend upon the speed. Okay, charge is invariant. You can say invariant to the speed of particle. But mass vary with a speed. But mass vary with a speed. Okay, mass is going to vary with a speed. How? If you remember this formula, m is equal to m naught root over of 1 minus v by c whole square. Have you remember this formula? Did anyone know about this formula? Anyone know about this formula?
No, sir.
See, this is a one formula which shows that how mass is going to vary with the speed. This is what rest mass. Rest mass means your original mass. Okay, when you are at rest, when your velocity is zero, this is called rest mass. Okay, when your speed is zero, that is a rest mass. Okay, you can see there is a factor of v by c, right? There is a factor of v by c. C, you know, v is what? V is a speed of the particle. It is a speed of particle. Now let us try to examine this properly. See, in real life, what is our mass? Maximum 50 kg. Okay, 60, 70, like that. Yes or no? Maximum in real life for a human being, how much weight we can have? 50, 60, 70. I'm talking about general, not I'm talking about Mukesh Ambani. Okay, son. Okay, he has a lot of weight, but for a general case, generally a person have a weight of 60, 70 kg, right? So this can be 60, 70 kg. How much speed we can go maximum? Maximum how much speed we can go? 200 kilometer per hour, 300 kilometer per hour, not more than that. Is it possible to go more than that? 500, 600? You can't. We generally don't go more than that. Okay, now what is it? See, so this factor is always less than 1 only, because we cannot go more than the speed of light. It is not possible for us, right? So this factor is always less than 1. So in real life, for a human body, if you see, the mass and rest mass both are same. Why? Because this factor is almost negligible. Are you getting my point? Are you able to understand or not?
Yeah, sir.
Yeah, so this factor is almost negligible, right? So in real life, if you'll see, apply for ourselves as a human body, you will understand that this formula is saying that mass is almost equal to the rest mass, and that is a true only. That is why we don't apply this in the, whenever we are solving in the, like, if you have covered class 11, those who have covered, they, you haven't applied this formula anywhere. Why? The reason is very simple, because we considered our mass is always constant. Okay, that is the first thing. But if you come to electrons and protons, I have told you the speed is going to be very much close to the light. If you say, remember, right now I have told you the speed of an electron in the first orbit of a hydrogen atom is 2.18 into 10 to the power 6 meter per second, which is very much close to the speed of light. Okay, that is 3 into 10 to the power 8 meter per second. So this factor is not going to be very much negligible, right? It is going to be some dominant factor. So over, if this factor will increase, overall the mass is going to what? Decrease. So that is what we are going to observe here. So that is why in electrostatics, when we are dealing with the particles, it is not possible to neglect the mass change with a speed. Why? Because here the speed is very much comparable to the speed of light. Are you getting my point? Say yes
Yeah,
or no.
sir.
Any doubt?
Yes, sir. No
Yes, sir.
doubts.
What is the doubt?
No doubts.
Okay, okay. So this is what important properties of a particles. Sorry, charge. So I hope you have understand all the properties. This is the first property we have seen. This is the second property, and these two are the third, fourth properties are there. So till here, if anyone have a doubt, please let me know. Now we are going to start the chapter, main important point of the chapter. This is the, see, whatever we are covering is, it's important with respect to the point of theory questions. Okay, and everything is important. Okay, don't skip, sir, what is this, why we are learning these properties and all, it is not important. No, no, everything is important. Till here, anyone have a doubt?
No, sir.
Okay, so let us start our chapter now. So our first topic is what? Coulomb's law. Okay, I hope everyone know about the Coulomb's law. Can anyone tell me what is Coulomb's law? First, let us see how much you know about the Coulomb's law. Tell me what is Coulomb's law? Anyone? Let me know what is
1 by
Coulomb's.
4 pi epsilon naught Q1 Q2 by R square.
Okay, that is you telling me a formula. I'm not asking formula. What is exactly a Coulomb's law is? Because see, we know
Gives
the
the
formula. Yeah,
it gives the electric force between 2 point charge.
somewhat correct. Anyone else want to try? Anything you know, please. Divya, Divya, you want to try? Divya, anyone else? Yogesh, Mohammed Qasim. Okay, you are in 11th, right? Okay.
The state that the electrostatic force of attraction or repulsion between two charged particles.
Okay, you are going on right direction. Try to make it basically see Coulomb's law is very it's basically it's a law, okay, and law does not consist of one single statement, okay. There are the multiple statements which are involved in a law. And see, the first thing is that there is a no any proof for law. Law is means it has been made and you have to understand it, okay. You have to understand. Now the problem why we are not able to solve a questions on Coulomb's law, why? Because we not understand each and every point of the law, okay. I will tell you, I will teach you Coulomb's law. You will understand that there are a lot of things which people don't know about the Coulomb's law, and then you will be surprised. Okay, these are the things are there in the Coulomb's law itself. Okay, yeah. So let us just start with this. So as see, Coulomb's law is not a single statement. There are the multiple statements are there. We will go through one by one each and every statement. So first statement, just understand it very properly. First thing, Coulomb's law state that if there is two charged particles at rest, then force between them act along the line joining their centers. This is a very important line joining their centers. This is a very important line. How? Let us see. Suppose there is a one charge here, there is another. Suppose there is a one charge here plus q, okay, and there is another charge here minus q, right? And suppose the distance between them is r. Now let us take this is also plus q. That will be easier to understand. My first question is that this charge will attract this q1 or q2. Which what is going to be happen? This q2 is going to attract q1 or repel q1?
It'll repel.
Repel, okay. So what is the direction of repulsion force? It will be like this, it will be like this, it will be like this, f1 F2, F3, or F4? Which force will be the correct direction? Which is the correct direction?
I think it's F4.
You think it's F4 like this, right?
Yeah.
Okay. Anyone else? One person is saying F2. Okay. Anyone else?
F2.
F2. Okay. See, the correct force will be F2 only. Why? Because this is a law which is given now. The force is going to act between the line joining their center. What is a line joining the center? These are the center, suppose these two. And if you join the line, you will get a line like this, right? Right, and the line joining the center is like this only. So the whatever the force is going to be, it will be act along this line only. Okay, this force is going to act along the line. Okay, so that is what they have mentioned, act along the line joining the centers. So these all are wrong, these all are wrong. Only the correct direction is F2. Similarly, this force on this charge particle will be like this, F1. It will be act in this direction. Okay, clear? And this is what we called as F. This we named it as F21. Sorry, yeah, F21. That is force on 2 due to 1, and this is named as as force on 1 due to 2. Clear? So that is the first statement given in a Coulomb's law. So most of the students, that they don't know how to apply the direction of force, whether it will be in this direction, that direction. That simple thing is that it should be always allow the line joining the center. That is the first statement given by the Coulomb's. Okay, clear? Anyway, he directly don't given the formula. Okay, everyone remember the formula, but he haven't given the formula directly. First he has tell the statements, and then he has went to the formula. Clear? First statement is clear. See, these statements are very important for you for solving the problems, I am letting you know. Okay, if you don't understand this statements, it will be very difficult for you to solve the problem. That is the first thing. Second thing, what he observed. Okay, second thing, he observed that force 1 2 F12 is equal to force F21. Okay, these two forces are same, right? These two forces are same. That is what he absorbed. Their forces are same in the sense magnitude, because force is a vector quantity, right? Force is a vector quantity, correct? So the magnitude is same. That is the first thing. The magnitude of the force is same. That is the first thing he observed. That is the magnitude of the force is same. Let me write it properly. F21 is equal to F12. That is the first thing he observed. Second thing, what he observed, magnitude, sorry. Yeah, magnitude. The magnitude of these two forces are same. If you observe these two forces, see, the magnitude is same and they are acting in the opposite direction, right? Then what is they are called? This type of forces are called as a, if there are two forces, they are acting in the opposite direction, their magnitude are also same, they are called as a, they are called as a, anyone speak, man? What is the this type of forces called?
Repulsive.
If you, sorry, it
Repulsive.
is it is an action reaction pair. Newton's third law of motion. It is a action reaction pair. It is a action and reaction pairs. Reaction pair, right? If you see, my F12 is minus times of F21. They are equal and opposite in direction. So these forces are forming an action reaction pair, right? So if they are in action reaction pair, so the net force on this system will be what? If they are action reaction pair, so can you tell me what is the net force, F net, from above expression? What will be the net force you will get? F net will be F12 vector plus F21 vector, right? So this term will be what? 0. The net force on the system will be what? 0, because they are action reaction pair, na? So if they are action reaction pair means they are equal and opposite to each other, so they will be added together and become equal to 0, right? So they are forming action reaction pair. So if this is a thing, then there is a one small question from SCV is like this. The question is very simple. If you have a very small knowledge, you can solve it. Okay, suppose there is a one charge. It has a mass of 2 kg. Okay, 2 kg is not possible, but okay, let 2 gram. Okay, and the velocity is given as let us take 3 meter per second. This is the initial condition. Okay, and there is another charge. Okay, this is at rest. This mass is 3 gram and it is rest. Now what will happen? This charge is moving in this direction. It will go and make a collision with each other. It will collide. Okay, after collision, what is happen? This charge, okay, this charge, okay, q1, this is q2. Q1 is moving with here with a velocity of 1 meter per second, and q2 is moving with a velocity of v2. I want to know what is the value of v2. Can you calculate what is the value of v2? Can you
2
calculate what?
meter per
Yes.
second.
Yes, sir.
2 meter per second.
2 meter per second. Okay. How?
3 meter per second initially it go, and after collision it will comes 1 meter per second. Remaining 2 meter per second will be there.
It's not like that. Uh, just try to think. There is a one small concept is there. It is not like that. What you are telling, or that you are applying a velocity conservation. Have you listened somewhere that velocity is always conserved? It
No,
is
sir.
not like that. So it's a velocity type of velocity conservation. Velocity conservation is not possible. Try, everyone try it. Ashima is showing that you are joining.
Sir, I'm here only, sir.
Okay. Just try this. See, first of all, tell me what is the net force on this system? This whole is as a system, na? This Q1 and Q2 forming a one system, right? What is the net force on this system?
5
Total
gram.
force. Sorry,
Net
what is the net force on this whole system? Q1 and Q2 is forming a system, right? So what is the initial force? Initial condition, if you see, what is the net force on the system initially?
It's 5.
No. Net force is what? There. What type of force is there? Electrostatics, right? Because they are charges. So what is the force there? Electrostatic force. I have told you the electrostatic force is always form a action and reaction pair, right? So the net force will be always equal to what? 0.
0.
See, here only we have mentioned. If you see these two particles, this particle will repel in this direction. If nothing is mentioned, always treat it as a positive charge. Okay. This Q2 will move this particle here in this direction. Okay. This Q2 will apply a force in this direction. This Q1 is applying a force on this direction. So the net force will be always 0, na? Because there is no external force, right? There is, I haven't mentioned anything external force is there, right? Second thing, I have told you the it is an action reaction pair, so the net force will be always 0. That I have also mentioned. If the net force is 0 and there is a no external force is there, then what is conserved? What will be conserved? Have you tried to remember? There is a one thing which is conserved when the net force on the system is 0, and there is a no external force is there. What is conserved? What is
charge
conserved?
is conserved.
Sorry.
Charge.
What you are saying, it's not clear. What you are trying to say? What is conserve?
Conservation of charge.
No. If you see, remember from 11th, okay? I have like your 11th is little big. Everyone's 11th is little big generally. Okay. Remember that. If if an any system, the net force is zero. Okay. Net force is zero. F net is zero. And no external force. There is no external forces there. Okay. Then momentum is always conserved. Momentum is conserved. So what do you have to do here? Simple. Initial momentum is equal to final momentum. You will get the solution. Simple. Have you got the point? Is it clear?
Yeah, sir.
So basically here you have to apply as momentum. See, just from these one statement is giving you a one question, and this is a previous year question, very old question it is. They have just framed a question from this single line. Okay, so that is what you have to understand the things very properly. So if the net force is zero, I can simply apply momentum conservation. Initial momentum is m1 v1 plus, let me do on the next page, right? Wait, momentum is conserved. Okay, I can do it like this. 1 minute. Yes. So obviously my m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 v2 dash. Now what is m1? This is m1 is you given 2 gram. This direction velocity I am taking positive to plus 3. This is 3 gram. Velocity is 0 initially. m1 is same, 2 gram. Velocity this direction velocity I am taking 1 minus 1 because I have taken this direction as positive. Plus what is m2? That is 3. Will v2 dash I don't know. Can you calculate v2 dash from here? How much you will get? 6 plus 2, that is 6 plus 2 is 8. 8 divided by 3, so v2 dash is 8 by 3 meter per second. Simple. Clear? Any doubt?
No, sir.
So basically, what you have to apply, simple momentum conservation. If the net force is zero and there is no external force is there, then obviously momentum will be conserved. If momentum is conserved, just apply it. Initial momentum is equal to final momentum. Simple. You just apply, you will get the V2 value. Clear? Any doubt?
No, sir.
Okay. Okay. Now let's move to the next. These are the three statements we have pointed out. First is the that it is always act along the line joining the center. Magnitude will be same. It forming action reaction pair. Now next point. That is what is the another point. The next very important point is the formula. Now it came to formula. Okay, directly don't come to the formula. There are these important statements are there which are present here. Okay, what is the important points? Formula. The formula state that force is equal to K Q1 Q2 by R square. Now the important thing is that what is this K? K is defined as 1 by 4 pi epsilon. Epsilon naught, I am writing in vacuum. Okay, epsilon naught. Epsilon naught value is what? It is what is basically it is. It is an absolute permittivity of free space. Permittivity of free space. And what is the value of K? Can anyone tell me what is the value of K? 9 into 10 to the power 9 Newton meter square per coulomb square, right? What is basically this Yeah, what is basically this epsilon naught is? Epsilon naught is 8.85 into 10 to the power minus 12 coulomb per Newton meter square. So this is the fourth, which is a very important statement. Generally we remember this only, we don't remember these two. Okay, without these two you can't, like, for solving question you have to understand each and every point of the law. Okay, now next important point, that is, from here we can say that the force is somewhat going to depend upon the medium. Okay, so remember this, we will discuss this is also in a separate detail, it is a separate topic, that how it is depend upon the medium. Okay, so basically it is going to depend upon the medium. So this is depend on, this force is depend upon the medium. Depend upon a medium. Okay, clear? Any doubt? So they, by using this, there is a one question they have asked you. Okay, let me ask you also. This is a previous year question. It's a very simple question they have given. They have told that this is charge q, this is charge q. They don't know. They have asked the value of charge q only, just by using this formula only. What they have said, suppose the distance is 1 meter. Okay, and k value is given 9 into 10 to the power 9. Okay, Newton meter square plus by coulomb square, everything is given. They ask what for force for F electrostatics to be maximum. They want the electrostatic force to be the maximum. How much they are? Maximum value of Q. What is the value of Q? F electrostatic has to be maximum. Then what is the value of Q? That is a previous year question. Just give a try. You have to find the maximum force. Okay, you have to calculate what is the maximum for, there will be force between them, right? What is the force? What is the force? The force will be, if you see what is the force between them, the force will be, F electrostatic will be, by the formula I can write K into Q1 into Q2 divided by, what is the distance? 1 meter square, right? So it will be K q square. Now I want this force to be maximum. I want this kq square to be maximum. Maximum means very big. Then what is the value of that q? You have to find this. How will you find it? What will be the maximum charge? Basically, if you see, this electrostatic force is now depending upon what quantity? It depends upon the charge, right? K is constant. K is constant, right? So only thing is left is the charge. What is the maximum charge we can give to anyone? Like suppose I have a particle, what is the maximum charge we can give? Say, what is the maximum charge we can give? It's a common sense question. Array, this force K is given, everything is in, Q square is there. What is the maximum charge we can give? Because this force is now depending upon Q, na? What is the maximum charge we can give? How much charge we can give to a particle? It is E. E is the charge, na? So what will be the force? K E square, right? That is the value of Q. So what is the Q then? Q is equal to E, simple. But whatever the other charge you will give, that is the integral multiple, na? I am asking the fundamental. The fundamental is E only. That is a what charge we can give maximum, right? Say yes or no.
Yes, sir.
Sir.
Okay, are you able to get it? It's a very simple problem. They have simply asked this. Okay, see, just now if you know the formula, you can apply it and you can just think. It's a small thinking, you can get the answer. Simple. Okay, most of you things are how I will think with respect of this. See, in option will be there now. With the option you can think of it. Okay, they have given the option, so from the option you can also get somewhere. Sometimes we don't understand how to think, so if we see the option we get an idea. Okay, this is how we have to think, like that. So you have to see the options also. Clear? Any doubt?
No, sir.
Okay. Okay. Now, okay, can you tell me what is the timing of the class? Because I don't know the timings. What are the timings of the classes? How much this for how much time this class is going to be? Hello, hello. Is I am audible? I am asking like, do you know about the timings? Like for how
No,
much time this class is going to be?
no, sir. They
No,
simply
sir.
mentioned 10 a.m. like that only they mentioned, sir.
Okay, okay. It's at 10 a.m. Okay, okay, okay. Till then, till here you tell like, have you understand the thing, or did like how you are liking the lecture? Is you are enjoying or not? That is very important. Till here, whatever I have told you, is it, is it okay for you, or is the lecture is going like is it tough for you, or is it easy to understand? How it is like that? Like I want you to tell me so that I can go according to you, because you have to understand me also. I have to understand you also, then only we can go in a proper manner, right? So like, yeah, let me know whether it is whether it is feeling hard for you to cope up with the things, or is it okay for you? Like yeah, Ashima, you can tell.
Sir, it is very understandable and it's okay for me, sir.
Don't do butter. I don't want don't do buttering. Okay, just tell. I'm just joking. Okay, it's okay. It's good to hear. And anyone else I can ask? Yeah, yeah, Divya, Divya. Divya, how you like the lecture? Is it okay for you also? She's not replying. Eh? Okay, someone has a doubt in slide number 6. Just wait for a minute. What is your doubt in this slide? It is better you can speak, because other it will take a time for you to type, right? It is better you can speak. Ash, Varun, yeah, you
Sir,
can speak. No issue. Yeah.
sir, I'm taking coaching in Ireland for the past 1 month. Is it fruitful taking online class in Impulse Academy? Because the schedules and all difference. There one topic will taken, here one topic will taken.
Sorry, I didn't understand. What is the doubt? Like, what is the problem you are facing with?
Sir,
Like,
no,
is it?
sir.
Yeah.
If I how to take online class from Impulse Academy means is it fruitful to me, sir? Because the schedules and all different only, no, sir. That's why I'm asking, sir.
Okay, okay. So, like, you want to know whether it is okay for you to take classes from here, right?
Ah, okay.
Yeah,
Yes,
it's okay. Like if you see, if you are taking, where you are taking another classes, where you are taking
sir. I'm a dropper in Allen, sir.
Allen. Okay, you are taking another classes, online classes in Allen, right?
No, sir. In offline classes only I'm taking, sir.
Okay, you are in Kota right now. Okay, okay. So
Ah.
you understand Hindi, or you don't understand Hindi?
No, sir, no, sir. In Coimbatore, they take in English only, no, sir.
Okay, so the thing is that, see, if you are taking classes in Kota, so
Mm.
like you can compare the things if you want. Like, better the thing is that you can compare whatever they will teach. I will teach the same thing. Okay, this all
Ah,
content is prepared from like a lot of different materials. Okay, and what about the schedule? If this schedule is looking okay for you, you can continue from here. Okay, because
okay, sir.
it's going to be more interactive for you. You can see there are going to be I guess in one class they used to teach 400, 500 student, right? like
Yes,
that.
sir.
So it will be difficult for you, okay. But if you want, you can continue and you can compare the things also. You will get that everything whatever they are covering, whatever me are giving is same. There is no difference in this, okay. Okay, I
No,
will
sir.
tell you.
Covering, I didn't mean covering, sir. I portion here. You take electrostatics, no, sir. They taking kinematics, sir. That's why I'm asking,
So then
sir.
it's good enough for you. It's a good. You cover the see. Some of the part of the kinematics is going to be used in the electrostatic, right? So you cover the both from like you go hand by hand. So your syllabus will be also complete fast, right? Because you
Oh,
have covered everything once also. You have covered the things once also, right? You have completed 11th and you have completed the 12th. So you have read the things one. Now you are reading it again. So it is easier for you to cover the things more fast, right? So
Okay,
just
sir.
try to, if they are teaching same thing, then I will tell you that you cover from me. But if they are teaching something else, then cover from there. That do kinematics as well as from there, and do electrostatics from me. So that's how it will cover your both the chapter. Like will be covered within the same duration, right? It will be beneficial for you, right?
Okay, sir.
And when I will teach kinematics to you, it will be you will goes under revision also. You will able to revise the things, right?
Okay,
Yeah.
sir.
Someone has a doubt conservation in momentum. What is your doubt in conservation momentum? It is a statement. What is the doubt in this? You can speak, man, so that it will be easier for me. Or like, what is your doubt? Okay, conservation of momentum. But net force is zero, no external force, so momentum will be conserved. Do you don't know how to apply this m1 v1 plus m2 v2? This you don't know. Array speak. Once more, once more. Array, once more what? Yeah, it's, what once more? Like, what is your doubt? That's problem. Okay, once more, sir, that problem. What is the simple thing, na? Everything is given. Simple net force is zero. Why the net force is zero? Because action reaction pair. So momentum will be conserved. Initial momentum is equal to final momentum. That is what I am simply writing. What is your problem? Is there in this? What is not able to understand? Net force is zero. Net force is zero. Momentum will be conserved. Momentum is conserved. Initial momentum is equal to final momentum. Simple statement. See, it's very important for you guys. Please make your basics little strong. It doesn't mean that you have to be like something you should know about physics because you are not reading it first time. Okay, basic things you have to know. Otherwise, it will be very difficult to complete the syllabus because we are not going to give exam for a board. We are preparing for competitive exam. Okay, so you have to be like that. Something you should know in basics, something you should know. And if you don't know, just note it down and remember that point for rest of your time. Okay, it is obvious that you will not remember everything. Sometimes people forget, right? But it doesn't matter. It doesn't mean that we should not remember it again. We should write. If we come to know, we just note it down and remember it. Okay. Yeah. Okay, next point. See, suppose there is a one charge particle q1 is there, okay, and suppose there is another charge particle q2 is there, clear, and suppose there is another charge particle q3 is there. What happened? Let us take an example, and everyone has to tell. Suppose this q2 is there, okay. Initially, suppose these two charge particles are, or suppose initially these two charge particles are there, right? Okay, the distances are. So what is the force on Q3? There is a force acting in this direction, right? Force 1 3, right? Okay or not? This force will act. Q1 will repel Q3 in this direction, right? Line joining the center. Is that okay?
Okay, sir.
Yeah. So now My question is that suppose this q2 has came, so this q2 will also try to apply the force in this direction, line joining the center, that is F23. Is that okay? I say yes or no. You are no, but like you have, when I'm asking, then you have
No,
to speak.
sir, not understand.
So basically, what is I'm saying? There is a, suppose there is a charge q1 is there. There is another charge q3 is there, right? The force between these two charges is F13. Clear? That force is acting. Now
Yes,
what I have done, I have bring another charge q2. When I bring
yes,
this another charge q2, this q2 will also try to apply a force on q3 in this direction, right?
yes, sir.
Right? So net force will be somewhere here.
Yes, sir.
This will be the net force because two forces are acting like this. So the horizontal component, vertical component will be added up and horizontal component will be cancelled down, right? So the net force will be someone in this direction, somewhere in this direction downward. Okay, that is not a problem. My question is that after bringing q2, what is the change in F13? My question is, suppose I bring, as initially q1 and q3 is there, this force is there, now I bring q2, so this one more force is coming here. So my question is that as I bring q2 in the picture, will be any change in F13, this force, the force which is initially acting, there will be any change in the this force after bringing q2?
No, sir.
No.
Not.
Yes, there will be no change because this force is depend on what? This force will be will be written as k q1 q3 by r square, right? Is there is any dependency of q2? No,
No,
it does not depend upon q2, right? So this force will not change. F13 is not change. It is the same. Similarly, is there is any change on F23? F23?
no,
No,
sir.
it will be also same, right? So what I'm trying to say, the force between the two charge particle, listen this statement very properly. The force between the two charge particle is independent of the third charge. Is that okay? The force between the two charge particle is independent of the third charge. It doesn't depend. This, see, net force is changing, that is okay, net force is change. Initially the net force is in this direction, now it is going in this direction, that is okay, net force is change. But is there is any change on the individual forces?
No, sir.
Yeah, so there is no change in that. So that is what the statement, last statement is given, and from there only we are able to apply the something called superposition theorem, that you say that net force is F1 plus F2, like that. So what is this thing is saying? The force between two charge particles, sorry, force between two charge particle is independent of third charge. Doesn't matter where the third charge is present, net force will be changed, but there is a no change on the individual forces. Clear? Any doubt?
Yes,
Yeah, doubt you can let me know.
No, sir.
Okay, so this is the basically the Coulomb's law. So Coulomb's law is consist of these five statement. If anyone have understand this all five statement, now I am giving you a guarantee. You can pick any book, you can solve any questions of Coulomb's law based on the Coulomb's law. You can solve all the questions if you have understand all these 5 points very clearly. So what are the 5 points we have covered? Just revise it once first. Just do revise it and let me know. You have done, then we will move further. Done? Everyone revise it?
Yes, sir.
Okay. So anyone have a doubt in these five statements which is given by Coulombs? Any doubt is there?
No, sir.
Only one person is saying no, sir. What about the others? Others. They don't have anything.
No doubt, sir.
Okay. So basically, these are the five statement, and now we are going to solve some problems on this. We will start with a very easy problems, and then we will increase our level. Okay. Just take a one simple problem. It is given everywhere. I hope everyone will solve. Suppose there is a charge q is there, there is a charge minus q is there is a charge plus q is there. I want to calculate, suppose 2q is there, let's q is there. I want to calculate f naught on this, net force on this charge, right? I want net force on this charge, and this is the square of side A. Please don't take time and just solve it within 1 minute. Just tell me what is the net force on this charge q. Fast.
Q square root 2 1 plus 1 by root 2.
Okay, so let's check. Basically, what will happen, how the things will work. See, this charge will going to attract this charge in this direction, right? Yes or no? Suppose this minus
Yeah, sir.
q is going to attract the q, right, in this direction. What is the value? K q square upon, what is the distance? A square. Why I am not considering sign here? Because I have considered the direction, right? I have put a direction downward now, so no need to consider the sign. Now this charge is going to attract in this direction, right? Sorry, not attract, repel. Na? Okay. So this is going to repel in this direction. Okay, clear? Because they are same nature. Na? Positive will repel, positive negative will attract. What is the value of that force? So we have to basically, this is F1. Let's say, so what is F1? F1 is k q square. What is this distance? The distance between these two charges, what is the distance?
Root
This
2a.
side is A, this side A, this is root 2a, right? This is 2a square. Now you see, we now it is all about vector. Now you should know about the vector. If you don't know about the vector, it is very problem. Okay, so this is one force, that is k q square upon a square, and there is another force like this, k q square upon 2a square. I have to add these two forces. What is the angle? This angle, what is this angle?
90
What is
plus
it?
theta.
90 plus, see
Theta.
this you will see, this is 90, this angle is 45, right?
Theta.
Because it is a square, so this angle will be also 45, so 135 degree, right? Clear? Yes or no? This is a square na,
Yes,
so
sir.
diagonals are intersect, bisect each other, so this angle will be 45, so this angle will be also 45, right? So total angle is 135, and there are two vectors. Or you can do one more thing, you can take components. If you have a problem with this, I will tell you the two methods. This is a first, let me calculate by this way. So what is a formula for this? See, this is f, then this is f by 2. So I can write like this, f square plus f by 2 square plus 2 times of f into f by 2 into cos 135. This is a one way of doing. There is another way of doing this. How? See, if you see this properly, it is look like this. This is method 1. Method 2 is like this. You can do like this also. This is k q square upon a square, right? And there is another vector going like this. See, we know this angle is 90, this angle is 45 degree. This is f by 2, this is f. So you can see that this will be component of this. You can take the component of this f by 2 cos 45, right? And this will be f by 2 sin 45. Now you can add these two and then take the summation of with this. So you will get basically like this. There will be one vector f minus f by 2, oh sorry, sin 45, f by 2 sin 45 degree, okay? And this vector will be f by 2 cos 45 degree. So now you have to simply, now you can, here you can apply under root of f1 square plus f2 square, because the angle between these two will become now 90, right? So that is another way of doing this. So it depends upon which way you want to apply. Clear? Any doubt here? Any doubt is there?
Yes, sir.
Only one person is saying, other persons, what about others?
No,
Any
sir.
doubt? It's simple only. Like I just made it little tricky because I haven't given a charge on this corner. If I give the charge on this corner, then it will be very simple. Okay, this then you won't get this force. This force will be cancel out. You will get only these two, and you will subtract and write the answer. But I just made it little complex just by removing this charge. Okay, that's why you are getting like this calculation. But you should know it's see what is electrostatic here. Electrostatic is this only, this much. Writing these two values, writing these two values is only the electrostatic. Now this all is vectors, this is all about is vectors. You should know how to add, subtract, okay, how to take the components. Very small things are there. This you should know. If you don't know about this thing, then it will create a problem. So it is a better, you can cover basics of vector from some from anywhere. Basically I will teach you vectors also, but you should know the basic vectors, okay? Because in the when you enter into the class 11, the first chapter they will teach you is the unit and measurement, and then they go for the vectors. So you should know about the vectors, how to add vectors, subtract vectors. Your vectors should be very strong, okay? Clear? Any doubt? Any doubt is there? Say yes or no.
No, sir, no doubts.
Okay, now you can take one homework problem also if you want. I'm not like interested in this, but you can take, it's simple only, okay? Everyone, I can say everyone, I hope everyone will do this. Suppose this is a triangle and there is a like plus q minus q plus q. You have to find f net on this, net force on this charge particle. This is your homework problem. You can take this and you can do this, okay? You have to find the net force on this charge q. Clear? Just note it down. Shall I change the slide? Everyone has
Yes, sir.
noted? Okay, clear. So next we will do some more questions when we discuss the scv, okay? Now let's go to the next thing, that is Coulomb's law in vector form. Like how to write the Coulomb's law in vector form, and when we are going to use this, okay? How, when we will use this? Okay, we study the Coulomb's law in vector form. My question is that when we have to use this, that is the important thing, na? So just first try to understand how to write it in vector form. See, I can tell you the lot of ways, but you should know how to write it finally. That is the only important thing. There is no meaning of knowing everything in detail. Just you should know how to write it. So suppose there is a one charge is there, that is q1, okay? And suppose there is another charge is there, that is q2. Suppose this is my origin, this is origin, Okay, this is my origin. What is this is called? The vector joining from the origin to a point is called as a, suppose this is point is O, this point is, suppose some A, this point is B. What is OA? Can anyone tell me what is OA vector? What is OA? What is known as OA? OA is known as what? And what is OB? What is OA and OB? Array, tell me what is OA and OB? No one know what is OA and OB. Array, what is OA and OB?
A vector.
OA and OB are called as a position vectors, na? They are position vectors. See, any point joining the origin will form a position vector. If you know the position vector of point A, if you know the position vector of point B, now you can write the force. So there will be force will be there in this direction, right? Suppose this is distance is R. Okay, R vector. The distance between this two is there. This will apply the force in this direction, right? F12 force on one. Sorry, force on two. Sorry. Force on 2 due to 1, and this will apply a force in this direction, force on 1 due to 2, right? This 2 with, how will you write the force? That is the important thing, right? So let us see force on 1 due to 2, how will you write? See, what is the formula is K q1 q2 by r square, right? That is a magnitude. Now for write in a vector form, you have to give the direction. The direction will be come from unit vector. You know about unit vector, right? Everyone know about unit vector?
Yes,
What is
sir.
unit vector?
Direction, showing direction.
Yeah, vector that is used to show the direction. It has a magnitude unity, so that is a unit vector. Now what is the direction of f12? F12 is in this direction, right? It is in this direction. So remember, just simple, 1 2 1 2. That means, how will I open it? I will open it like this: k q1 q2. I will write like this: r1 minus r2 mod q, r1 vector minus r2 vector. Simple. If you are writing 1 2, then here should be 1 1 2 1 2. Simple. Similarly, f21, if I want to write, how will I write? K q1 q2. What I will do? R2 minus R1 mod of q, magnitude. This is the magnitude of the cube. Okay, you have to first find the magnitude, then you have to do the cube, into r2 vector minus r1 vector. Simple. Just remember this: f21 2 minus 1, f12 1 minus 2. Simple. There will be no doubt, no need to remember all these things. Just simple, you should know how to simply write it. Clear? Any doubt on this, on writing the Coulomb's law in vector form? Anyone have a doubt in writing it?
No, sir.
It's very simple. Just you have to remember this thing. Okay, just you can write like this in a simple manner. Okay, now the thing is that question is that where we are going to use this. Okay, we study this. Remember, we have to put q1 and q2 with sign. That is very important. Okay, with sign. In vector form you have to put it with sign. See here, if you have seen, we haven't considered the sign. Why? Because we have considered the direction, so no need of sign. But here we have to put everything with sign, then only we can calculate. Just I will give you one example why we are going to use it. We generally use it for the 3D question, the questions in which involve a 3D figures. For example, okay, so let us consider this. Suppose this is our cube, and very simple question I am giving. Suppose q is placed on all the corners. All the corners we have a q. Okay, it is a cube, and the side is a. Okay, my question is that what is the net force on this? What is the net force on this? How will you solve? Is it possible to apply the normal concept, normal thing as we have done earlier? Is it possible here to apply that? You can apply, but it will be very time taking for you. You can apply. It is not like that you can't apply. What we have done earlier, we have basically, if you see, we have basically what we have done earlier, we have considered the force on by the all the charges, then we have done a vector sum, right? My question is that, is it, suppose this is minus q, let make it little tricky, minus q, yes. Now my question is that, is it possible for you to consider the force by all the charges on minus q1 and then add it? That is a general approach, right? That is a general approach, yes, because we have done the same thing earlier also. What we have done in this question, if you see, we have considered the force on q by all the charges and then we have done the vector sum, right? So in this figure also we can do the same thing. We will calculate f1, then f2, then f3, then f4, then f5, then f6, then f7, like that we will do, and we will do the vector sum, right? Sorry, f1, f2, f3, f4, f5, f6, f7. Yeah, 7 forces only. 1, 2, 4, 5, 6. Yes, we have to consider 7 forces and we have to add it, right? My question is that, okay, let I will consider the 7 forces and I will add. Is it easy to write the 7 forces, because now it is in 3D, it is not in 2D, right? What we have considered initially is a 2D figure. It is a 3D figure. Is it easy to write the forces for
Yes.
you? So here you can't write the forces easily. So that is why we are going for a vector approach. So whenever the problem is given in 3D, okay, then always think for a vector. Okay, always think for a vector, that will make your calculation easy. So how will you do? I will write that my net force is same, F1 plus F2 plus F3 plus F4 plus F5 plus F6 plus f7, that is okay. But how will I write the f1, f2, f3, f5? That is by using vector. How will I use vector? Let us see here. First, can you tell me if this is x-axis, this is y-axis, this is z-axis? Okay, oh, sorry, one thing is wrong. 1 minute. Let me replace this. Yes, this is z-axis. Okay, now can you tell me one thing? What is the coordinate of this charge? If I am considering this as origin, right? This will be origin. Oh, sorry, this is also, I put it wrong. Yeah, now it is okay. So this will be origin, because if this is x, this will be y, this will be z, then this is origin. Now the side is, I told side is a. Can you tell me this coordinate? Can anyone tell me what is the coordinate of this charge? If this is origin, this is x-axis, this is y-axis, this is z-axis, the side of the cube is a. What is the coordinate of this charge? Can anyone let me know what is the coordinate of this charge? What is the coordinate here? Are you able to follow me? What I am trying to say, we have to use the Coulomb's law. We have to use the Coulomb's law in vector form, right? So for writing the Coulomb's law in vector form, we should know this point, right? We should know this point. Then only we can do r1 minus r2 vector. Na? Otherwise, it is not possible to do, because OA is what? OA is position vector, which is equal to r1 vector. Okay, and OB is a position vector that is equal to r2 vector. R1 vector, R2 vector. So we have to know R1, R2. So for that, we have to know the points. So that's what I am asking. What is the point for this charge? What is the coordinate for this charge? If this is origin, this side is A, what is the coordinate of this charge which is on the x-axis? What will be the coordinate? A, it's simple math, simple math. What is the coordinate of this charge? Are you able to understand this or not? Say something, yes or no. You are saying not responding anything.
0, 0, A. 0, A, 0.
See,
See,
it is first. You tell me for this charge, what is the coordinate?
A comma 0 0.
Yes, a comma 0 0. Why x and y and z will be 0? Because it is on x axis, right? And how much distance is there? A distance. So the x coordinate will be a 0 comma 0. Simple. Now tell here this coordinate. This will be on y axis. So which is 0?
0
X and z
comma
will be
A
0,
comma
right?
0.
So 0 0 and only a will be there. Similarly, on this coordinate, what is a 0 comma 0 comma a? Now, how will you write this coordinate? This coordinate is very important. How will you write this? This point is in which plane? It is in y and x plane. You can see this point is in y and x plane, right? XY plane. So
A
x will be there, y will be there, z will be 0. Suppose some point is there which is in xy plane, so obviously x will be there, y will be there, z will be 0 right now because it is in xy. So z coordinate has to be 0. So my x will be how much? A, y will be how much? A, and z will be 0. Similarly, if you see this point is in which plane? Y and z plane, right? YZ plane. So if it is in YZ plane, my x will be 0. So x is 0, y is a, z is a, right? Similarly, come to this point. This point is in which plane? It is in x, y plane, x, y plane. So my, sorry, x and z plane, not x, y, x and z plane, x and z plane. So y will be 0. So x is a, y is 0, z is a. Now come to this point. This point is very important. If you see this point is in free space, which is in all the planes x, y, and z. So this will be a, comma a, comma a. So like this, you should know how to write the coordinate of each point. This is a maths. This is not a physics. Okay, this is a pure maths. You should know how to write the coordinates. Okay, in a cube. Anyone have a doubt in writing the coordinates? Please let me know.
No doubts.
Okay. So after this, we know the coordinates. Now let us find the force. So what is F1? Suppose let give the number. Okay. Let's give it number. Then it will be easier. This is suppose 1. This we are giving 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. Everyone write F1, F2, F3, F4, F5 like that, F6 using this vector form. What you have to do? First tell me F1. One person tell me F1. What is the F1? What will be F1? K, Q1, Q2, Q minus Q, right? Then R1 vector minus R2 vector. My question is that you will do 0 0 0 minus this, or you will do this minus this. What you will do? That is the important thing. You will do this minus this, or you will do this minus this. First, tell me what will be the direction of the force. What is the direction of the force? If you see the direction will be like this, right? So you have to always do final minus initial or head minus tail. You have to always do head minus tail. Okay, you have to always do head minus tail, or you can do tail minus head also. It doesn't matter because it is a vector, so it will be always, answer will be always come correct only. Okay, it is a vector, so you can do anything, whatever is you required, answer will be always come correct only, because there will be difference in the minus sign that you can see and correct from the option. Okay, that is doesn't matter that much. So what you have to do, you can do this minus this also, and this minus this also, doesn't matter, it will be difference of minus sign only. Okay, if you do this minus this and this minus this, the difference will be minus sign, so you can adjust after, at the end of the answer you can adjust, right? Okay, so what will be the thing? R2 minus R1 or R1 minus R2, so what will be how much? 0 0, this will be a j cap, right? Because only y coordinate is there, x and z are 0 0, so a j cap mod whole cube, this is a j cap, right? This is f1. Similarly, tell me what is f2. Tell me now. Now you have to tell, then only I will write. Tell me what is f2. What is f2? Anyone have a doubt in f1?
No, sir.
Okay, now tell me what is F2? What is F2? K,
Q square by uh,
K,
A.
Q and minus Q. You have to consider sign also, na? See, I have mentioned you have to consider sign. While vector form, write with sign. Okay, write with sign. So it will be K, Q and minus Q. Minus Q. Okay. Now what is the in denominator?
A I cap plus
A I cap plus
A
A
J
J cap.
cap
Magnitude whole cube A I cap plus
plus J cap A J cap.
I can directly write this. Just I'm removing one step. I can directly write like this. Is that okay? Root 2 a cube. Is that okay for you? Because what is the magnitude of a? What is this value? Ai plus aj. Magnitude. What is the
Root
magnitude?
2
Magnitude is this only, na? Root 2a, right? It will be root 2a. Everyone know how to find the magnitude of the vector. They say yes or no. Everyone know or find the magnitude of the vector or not. See, only one, two persons are replying. If you are not attentive, if you are not answering me, how will I understand you are understanding or not? I'm not here to teach only to one or two person. Okay. How to find the everyone know how to find the magnitude of a vector. See, still no one is replying. Everyone know how to find the magnitude of a vector. Did everyone know how to find the magnitude of a vector?
Yes, sir.
What about other? Why they are not answering anything? Leave it. See, the thing is that now, if you give the whatever the way you are responding, the way I will teach. If you are not responding, I will not teach like that. Okay. If you are responding properly, then only there is a meaning of teaching. Otherwise, what is the meaning? Why should I waste my time here? This is not my job to tell you how to find the magnitude of the vector. If I'm asking you, reply me quickly.
Root of A square plus.
So it will be what? It will be root of a square. Simple. Okay. So that's what I have written. Directly I have written this value. Similarly, tell me what is F3? What is F3? What is F3? What is F3? What is F3?
KQ minus Q by AI cap whole cube.
Yeah, magnitude whole cube. That is AI cap.
AI cap
Yeah. What is F4?
F
K Q
KQ minus Q
divided
uh,
by.
A J cap plus K cap the whole cube. Root 2 A
See, this is the my four. Okay. Yes. Yes. This is root two
A
A whole cube. What is this value?
J cap plus A K cap.
A K cap. Right. Similarly, what is F5?
F K Q minus Q by A K cap.
Sorry. Sorry.
A K cap.
Okay, okay, AK cap, right? Okay.
F6.
Similarly, what is F6?
F6. KQ minus Q by um, A A J cap A I cap plus J cap
Okay, AI cap,
plus A K cap.
AK cap, root 2 in AQ. Directly, you
Uh,
can say root 2 AQ. Root 2 AQ. That is A.
I cap plus A K cap.
AI cap plus AK cap, yes. And what is F7? What is F7?
Sir,
What is F7?
K
K?
KQ minus Q by uh, A J cap A I cap. Sir,
You have did a mistake while writing F6. Okay, one minute. This is F6 will be not this, na? See, F6 is what? This is the charge, right? This is AAA. So it will be
oh,
root 3. Root 3A
okay,
whole.
okay, okay.
Okay. This will be AI cap plus AJ cap, AK cap. You have told me the another one. And this will be how much? This is
Root 2 A square.
root 2A square.
Root 2 A whole cube. I
AI cap plus
A
A
K cap.
K cap. Yes. Now you can simply add this. Now, in spite of writing AG cap, can I write like this? AQ, is that okay? Because mod of AJ is A only, right? So wherever this thing I can remove, like mod of, here you can see mod of this thing I can write it as AQ. Is it true or not?
Yes, sir.
Say yes, I can write it like this. So similarly here also I can write it as AQ. Anywhere else? Okay. Now you can add this. You will get the final answer. Clear? So that is how we use the vector form. Okay. If you see with you are taking, I'm teaching you, that's why it is taking time. But if I have to solve this, I will write it within less than 10-20 seconds. I can write all the forces and I can add it directly. There will be no problem. Okay. So let's just try to solve one problem. Okay, if you understand this, then just solve this. Try to solve this.
Sir, can you say that how to write the denominator?
How to write what? What do you want to know?
Like the denominator which you have wrote root 2
See,
is.
denominator is nothing, just the magnitude of this. Whatever you are doing here, na, a R2 minus R1, just take the magnitude of that. You know how to take the magnitude of a vector. What is how to take the magnitude of a vector? The vector for any vector, suppose it is a I cap. Sorry, suppose it is a I cap, b j cap, okay, and c k cap, right? So just take the magnitude of this, a square plus b square plus c square, right? So what is happening in the denominator, whatever we are doing here, here we are writing r2 vector minus r1 vector. So whatever we are getting here na, we are taking the magnitude of that. Suppose we have got here a I cap plus a j cap, right? A k cap. So we will take the magnitude of this, simple, a square plus 0 square plus a square. So that is what we are getting, root 2a, right? This we are writing in the denominator, simple, and doing the cube of this. Why the cube is this? This is from the unit vector, okay? So it is cube of this. That is a simple we are doing. Whatever you are getting here, r2 minus r1 vector, just take the magnitude, write the cube here. Just take the magnitude, write the cube. That is a simple thing we are doing everywhere.
Yeah, sir, understand.
Okay. Okay, just try to do this. Are you able to understand what does this geometry look like exactly?
Pyramid.
Yeah, it's a pyramid basically. Okay, the bottom is a square but it's not getting like a square. Okay, bottom is a square only. uh, Let me make little tricky for you. This is side is a, and all sides are a only. The height from here to the center is 2a. The height is 2a. I keep the charge q here. That there is charge q. This is charge q. This is also q. This is also q. I want to calculate f net on this charge. That is a question. You have to calculate f net on this charge. This is a one homework problem. Okay. Everyone has to solve and tell me the solution of this. Okay. No one. I will ask everyone if anyone. At least you have to give your effort to try to solve it. It's a simple thing. We have covered this, right? There is a one more question. You can try. This is a good question. Uh, okay. Suppose there is a 1 coulomb charge is there. Okay. It is kept at origin. This is the origin. This is my x-axis. This is my y-axis. Okay. Then at 1 meter I have keep another charge of -1 coulomb. Then at 2 meter I have keep the another charge of -2 coulomb. Okay, clear. Then at 3 meter I have kept the charge of -3 coulomb. Then at 4 meter -4 coulomb. Like this up to infinity. See, this all charges will apply a force on Q1. Okay, so force on 1 coulomb, this charge, force, net force, 1 coulomb. You have to calculate the net force on this 1 coulomb charge. Okay, this charge. I want F net on this. What is my net force? That is what I want. Clear? You have to this is a little mathematics. Okay, when you will write the expression you will get to know a new thing. Some series, it will obviously it will make some series because it is going to up to infinity, so it will make some series and try to resolve that. It will test your some little mathematics, very basic mathematics, because this type of question generally come in your exam. They will so some important series you should remember. Okay. Okay, so that's it. So 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 how is the lecture? Have you enjoyed it? Have you like understand whatever the concept I want to deliver you? Say something, yes or no. Have you understand the concept, or any doubt is there? How is the class? Is it going too fast or slow or whatever? You can give the suggestion, whatever you think. Is it okay? Are you able to follow each and everything, whatever I am trying to say? See, it's now regularly you have to revise the notes, you have to read NCRT, you have to try to solve the previous year problem questions. Start doing from today only, okay? And see, it's all about how much you are showing your efforts. That is going to be work, okay? Clear?
Yeah, sir.
Till then, any doubt is there in today's session?
No, sir.
Okay,
No
so
doubts.
okay. So thank you. Now in tomorrow session we will continue from here further. Okay. And see, in starting I am going very slow, but as we will finish the electrostats, then most of the concept will be covered. So after that, we will we will move little faster. Okay. Till then, okay, we will cover the things Tomorrow, please try to solve the questions, whatever I have given as a homework. Tomorrow we will discuss. Okay? Till then, okay, bye.
Okay, sir.
Okay,
Okay,
bye.
sir.